this video, we're going to learn about functions in Python. And we're going to get started here by grabbing our tile position for the player in the world, storing that as X, Y, and Z. And now let's create a tree. So we'll do world.setBlocks. And the tree needs to have a trunk. So we'll start our trunk where we are at X, Y, Z. And then we'll make the tree trunk 3 units high. Okay? And block type 17 is wood. So this will build the trunk with wood. Okay, now let's go ahead and copy the code, and on our next line we'll paste it, and now we need to build a layer of leaves. So bottom layer of leaves, and leaves are block type 18. So we're going to change that to an 18. Now we want our leaves to be up above the tree trunk, which was from Y to Y plus 3. So let's make this layer of leaves be at Y plus 4. Okay? And then we'll make it a 4 by 4 square, so X minus 2, X plus 2, and then same for the Z. We'll do Z minus 2 and Z plus 2. Let's go ahead and grab that line of code. We'll copy it and paste it, and now we'll build the top layer of leaves. So our block type will stay 18. This next layer is going to be one higher than the first layer, so we'll change our Y's to be plus 5. And then we'll make this square a little smaller. So X minus 1, X plus 1, Z minus 1, and Z plus. Okay, so that should hopefully, if we make any mistakes, should build us a tree where we're standing. So let's go ahead and try that out. So we'll run our module, come over here to Minecraft, we'll move forward a little bit, and then we'll turn around. There's our tree. Okay, if we move a little bit further out, maybe we can see our tree a little better. So turn around, there it is. There's our tree. Okay, it looks great. Okay, but what if I wanted to build a whole bunch of trees? So let's move over here to a new part of our Minecraft world. Okay, this looks like a good spot. Don't have a lot of trees around us. And if I wanted to build a whole forest of trees, I would have to copy and paste this over and over and over again. And that starts to get redundant, having lots of the same code repeating. So what we're going to do instead is make a tree building function. So we're going to come up here after we create our world, and we're going to do def build a tree. We're going to create a function for building a tree. Okay, when I press enter after the colon, notice Python tabs me over so that everything that is underneath that tab is going to be part of this function. So let's grab our tree building code, and we're going to go ahead and move it into this function that builds trees. Okay, now in this function, we need to have X, Y, and Z values in order to build the tree. So we're going to pass those values into this function by making them the arguments. Remember, arguments go inside the parentheses. Okay, those are the 3 pieces of information that have to be provided when this method or function is called so that it can run. Now we're going to make a comment, and instead of using the hashtag for our comment, since we're going to do a multi-line comment, let's go ahead and do a docstring comment. So 3 quotation marks. Notice that turned everything green that came after it. Okay, if I want to make it just those 2 lines, right, I start and stop with 3 quotation marks. Everything between those quotation marks will be a DocuSign comment. So in this comment, I'm going to describe what my function does and what sort of information needs to be passed into the function where those arguments are located. So this function will build one tree using x, y, and z arguments, which must be either integers or floats. And that is an in-program comment that explains the purpose of this function, right? What this function will accomplish. Okay, so now we've grabbed our position in the world, and we can now call that function. So we'll say, let's build a tree, and we're going to pass in our x, y, and z position. We don't want the tree to be right on top of us, so let's move it a little bit away. So we'll pass in our x position plus 5, right? So it'll be 5 blocks away to us in the x direction. Same thing for z, right? Let's move this 5 blocks away from us in the z position, but we'll go ahead and keep our y value the same, and that'll build a tree. Okay, then we can build another tree. So let's put this one at x minus 5. We'll put this one as 5. And then we can build a third tree. So maybe we'll put this one 10 units away. So we'll do plus 10 for each of those. We can build another tree, and we'll put this one minus 10 in each of those directions. Okay, and we can just keep building trees, as many as we want, by calling this build a tree function that we've created. So this one, let's put this one 15 units. We'll make that a plus 10, right? And so on. So you can play with this to create a forest of trees all around yourself in the Minecraft world. So let's go ahead and run and test that out. Okay, and we can already see some of the trees, right, that popped up over here. There's some more over here. Right, there's some behind us. So we've got, if we climb a little higher, get a bird's eye view, right, we can see all the trees that we created using our function. Okay, now functions are really useful for getting rid of redundant code. So let's go ahead and open up this refactoring program, and we'll take a look at this code. So we can see there's a lot of repetition in this code, right? The position function is being called every time. The position x, y, and z is being grabbed every time. The set block is being grabbed every time, and the sleep function is being used every time. So it looks like instead of having this code happen 3 times, we could define a function that does what we're looking for this code to do. And it's setting a block each time. So let's say that this function is called lay blocks. Okay, so each time we grab this here, we'll tab it over and put it inside of our function. So each time the world.player.getPosition is called and the x, y, and z coordinates are captured. Right here in this one, they're subtracting 1 from the position, but notice that's what happened in our set block in the first time. So excuse me, if we want to get rid of the redundancy of this code, right, we can just have that be an x, y, and z here. Okay, now the laying the block, okay, that's going to get the player's position, grab its x, y, z coordinates, right, then it's going to set the block, but notice that in the first time this block type is 103, then it's 41, then it's 57. So those block types are changing. So we could send a parameter in, right, or an argument of the block type and then we can use that information when we set the block, right? So we'll call this B type for block type, since type is a reserved word. So we're going to pass in the block type and then use it when we set the block. Okay, now we can also see that sometimes the X, Y, and Z positions, that information is changing in the functions. So let's, instead of having that information grabbed here from the position, let's go ahead and have that user tell us the X, Y, and Z that they want used in addition to that block type. Okay. Each time they're sleeping, it's 3 seconds, so we can keep that a 3. We don't have to have them pass that information into it because that's consistent across all of this code. Okay, so now we have our function lay block. Okay, now we are going to go ahead and get our player's position one time. Right? We don't have to do it over and over again. So we'll get that player's position, and that'll be their X, Y, and Z coordinates that we're going to use when we lay our block. Okay, now we can call our lay block function, and we need to pass in the place that we want the block to be laid. So the first time it was called, okay, they laid the block right at the X, Y, and Z position. Okay, but that was at Y minus 1. And the type of block that they used the first time was 103, right, which is melon. Okay, then the second time that they laid down a block, they did a Y minus 1 again, but the block type that time was 41, which was gold. Okay, and then the third time that they laid the block, okay, then we had the Y minus 1, but we could mix this up a little. Maybe we'll make it a Z plus 1 this time, and an X plus 1. Right, we can put these blocks wherever we want them to be, and that one, I believe, was 57. I think 57 is diamond. So when we run this, we're going to end up with the melon going right on top of the gold because they're both at the same X, Y, Z position. So let's go ahead and make this one be like 5 blocks away so that these are all at different locations. So we'll go ahead and run our module, and then we can come look and see, and there's our melon block. Okay, there's our gold block, and there comes our diamond block. So we can see all 3 of them showed up this time. Okay, now let's make this a little bit more interesting by having the user tell us the type of block that we want them to use. So we'll say our block type is equal to input, and we'll tell the user to enter the block type as a number. Now remember, input is going to enter or store whatever's entered as a string. So we're going to need to cast that input as an int. Oh, I think the parentheses go the other way actually. So we're going to cast this input as an int so that it stores it in block type as an integer, a number value. Now if I leave it here and then I were to change this to the block type, I would need to copy paste that every time I called that function. So instead of putting it there, let's put it inside of our function, and then the user won't need, or the calling function won't need to tell us the block type because the user is going to go ahead and enter that block type each time that, that a block gets laid. Okay, so the first call, okay, there's our second call and our third call. Okay, and now we're going to not know what the block types are, because when the function gets called, it's going to pass into the arguments those coordinates that we want the blocks laid at, but the block type is going to be entered directly by the user. Okay, so let's go ahead and run. And here's our prompt: enter the block type as a number. So we'll do 103. And there's my melon block. I can see it got laid down in front of me. Okay, now we can enter the next block, 41. And there I can see the tip of my gold block that got laid. And now we'll enter 57 for the diamond. We'll come up into our Minecraft world, look around, and there's our diamond that got laid. Now this method, function that we defined, lay block, is currently a void function. It's not returning anything to the place that was called. But I could change that. So if I wanted to assign a variable, so we'll call this message equals, and we're going to call this function lay block, but after we lay the block, let's return to the calling function block type was, and then we'll concatenate with that, and we'll cast our block type as a string so that it can be concatenated onto excuse me, onto our string literal that comes before it. Okay, so now when we run that function, it's going to return this string, this concatenated string, and store it as message. So I should be able to do my world post to chat, and we can output that message then to the chat. Okay, so I'm going to go ahead and copy, and we'll paste that here. There we go. We'll paste that here again. So this one will be message 2, and then this one will say message 3 to chat message 3. Okay, so let's go ahead and run. Well, before I do that, I'm going to go to a clean spot in my Minecraft world. Let's get laid. Let's see if we can find someplace flatter. There we go. That looks good. So it will be on the beach. And let's go ahead and run our module. Okay, so our block type will start with 103. And here it tells me block type was 103. See, that got returned from that function so that it could be posted to the chat. Okay, now our next block type, 41, and there's posted to the chat. Block type was 41, and then 57. Right, block type was 57. And we can turn around in our world and see there's our 3 blocks: gold, melon, and diamond. Okay, we could make this even a little bit more fun. If we come up here and tell them instead of entering the block type as a number, let's just tell them to enter the block type, and we'll give them some choices. So let's say gold, diamond, or melon. And then that means when we return the block type was plus the block type, we no longer need to cast that result as a string because it's already being stored as a string. But since it's a string, they're typing in a word, we cannot use block type here because that argument in the function for set block has to be a number value, an integer. So we're going to have some conditional statements to convert their string into an integer. So if block type equals gold, okay, then we're going to have another variable b type equal to 41. Okay, and b type, that's going to be set into the argument of the set block function. Okay, then we'll do an else if the block type equals diamond. Okay, then we'll set the b type equal to 57. And then if the block type is equal to melon, okay, then we'll make the b type equal to 103. And you could add as many different block types as you wanted to this list, right, and just have their conversion values there. Okay, so now we can end with an else, right, so that if it's none of those things, we could then set our block type equal to just 0 for air, right, if we wanted to, or you could set it to stone or what other default that you would like. Excuse me. And then in that instance, your B type would be set to 0. And then in that instance, we would also want to change block type to be that we used air instead of whatever it was that their invalid entry turned out to be. So let's go ahead and try this out. Okay, so we're prompted to enter our block type. So let's try gold. And our chat tells us the block type was gold. Okay, if we come up into our window, we can look around for our gold block. I think it might be inside of one of these hills. Let's tab up and we'll come plop ourselves in the grass here. And then we'll run again. Shell and run. So we'll start with gold. And then we'll come up and look for our block. Oh, there it is. I can see it sticking out back here. So there's our gold block that got placed. We'll try diamond. Okay, and it tells us our block type was diamond. So let's come up here and look around. And there's our diamond block placed over here. Okay, then we can come down and make our block melon. Okay, and I think I have an extra space in here. I think that's why it didn't read it as melon. So block type was used air instead, and that's going to be positioned then in our world wherever we told it to go. Okay, so we can see all of our conditional statements, right, we're working, including our else, right, we used the air instead. That should be lowercase u. Okay, now there's one more thing that I want to talk about, and that's the scope of variables in your functions. So let's back this up and we'll try just a little bit more of a simple example. So let's say we had a variable called eggs, and we've got a dozen eggs. And then we're going to define a function that will increase the amount of eggs. Okay, so it's going to say that we take our eggs and we add, so plus equals 1, right? That would increment our eggs. And then we'll print the value of eggs to make sure that our function is working. Okay, so let's come down and call that method. We're going to increase eggs. Okay, now when we run this, we're going to get an error. So let's go ahead and give it a try. Here's our error. It says local variable eggs referenced before assignment. And that's because the eggs variable was assigned outside of this function. No values were passed into the function that have to do with eggs, so eggs cannot be increased or incremented inside the function. And the way that we fix that, right, we have to change the scope of this variable so that it can be accessed inside of our function. So let's go ahead and try assigning it first inside the function. Let's say eggs is equal to 0. We increment eggs and we print eggs. Okay. Now if we come down here and we print eggs, let's see what the difference is in the output. So if we code trace our way through here, right, when we call the increase eggs method, that's going to take the eggs that's inside the function, it's going to increment it and output 1. But when we print eggs, it's outside of the function, so it's looking at this variable whose scope is outside of the function, and it's going to print that value of 12. So let's go ahead and run and see your output 1 and 12, just like we thought it would be. And this has to do with the scope. So eggs that's inside of the function, its scope is restricted to inside of the function. Right? This eggs that is outside of the function, its scope is restricted to things outside of the function. If I want the eggs to be the same inside and outside, then I need to come down and instead of assigning it its own value in the function, I say that I'm using the global variable eggs. That variable whose scope is outside of the function is now going to have scope inside of the function. So when we run, it's going to take that 12 from outside because we're using the global variable eggs. It's going to increment it and print 13. Now because that scope is global, it also changes the value of eggs outside the function. When it increments, it changes the original value. So this is going to be 13 as well.